finish lesson 14, just a couple things that I thought were important enough to do a video about. Okay, theorem 14.8 says the central angle of a regular polygon, the central angles of a regular polygon are congruent. So let's just take this figure that I drew down here, or copied. Let me get a different line color. So if we had the center of this circle right here, and we drew in central angles, kind of like a central angle in a circle. So if I drew in, whoops, my only problem is the lines that come with this thing are white. Just don't really, oh, actually they're gray. Today they're gray. Good. Okay. So if we drew in all the central angles, we would be drawing all these angles like this. Let's just draw them all in. All right, now let's look at the theorem. The theorem says the central angles of regular polygons are congruent. So we're basically saying that this is going to be congruent to this, is congruent to this. These are all the central angles. All right, keep that in mind. Now, the measure of a central angle of a regular polygon is equal to 360 divided by the number of sides. So if we're going to do this one, we would take 360 and we would divide it by the number of sides. This is a six-sided figure, so each of the central angles are going to be equal to 60 degrees. And finally, the third part of this theorem is the radii of a regular polygon bisect the interior angles of a regular polygon. So let's just draw that in here. So this is going to be congruent to this. So they're going to bisect them all. So they're basically all going to be the same because they're all the triangles are going to be the same. All right, knowing that, let's try a problem. So we want to find the measure of the central angle of this figure. Well, we just did that. The measure of the central angle is right here, 360 divided by 6. So the 6 central angles are 60 degrees. So that's the first one. The length of the radius. Well, they have to tell us a little bit more than this. They're going to tell us that this side down here is 14. So that's going to tell us that all of the radii are going to be the same. Because it's a regular hexagon, we know that this is going to be congruent to this, right? And if this is 60, then these are going to have to be 60. So it's going to form an equilateral triangle. So the radii is going to be 14. So we'll put 14 here and 60 degrees here. And the opossum, now that's a word, it sounds like an animal or something, opossum, but it's called an opossum. And what it is it's the perpendicular line that comes right down here and is a perpendicular bisector of that angle in this side. So we're going to take it the whole way down there. It is a right angle. So we need to find the opossum. Now, as you can see, it's a 30, 60, 90 triangle. So this is going to be 30. We talked about this in class. This is a perpendicular bisector, so this is going to be 7 and this is going to be 7. So the one opposite the 60 degrees is going to be 7 square root of 3. Remember that we did this in class briefly, but it's worth repeating. If I have a 30, 60, 90 triangle, let's just do it the same as that one. All right, so we have our 30 is up here, our 60 is here. If the one opposite the 30 we call x, the right angle is going to be 2 times whatever x is, and the one opposite the 60 is going to be x times the square root of 3. So in this case, x is equal to 7, so it's going to be 7 square root of 3 for the one opposite the 60 degree. All right, let's move on. The side length of a regular pentagon. Now obviously I'm not going to draw a pentagon, that would be just a disaster. We are supposed to find the length of the opossum to the nearest hundredth and the area correct to the nearest whole number of this whole regular pentagon. So a pentagon is going to have 10 sides, so I'm just going to pop out one of the little triangles. Like here's our 6-sided figure, and one of the triangles would be this would be the triangle that we're going to pop out. So we're just going to pop that out of our 10-sided figure. So there it is. Now there's going to be, if it's a 10-sided figure, it means there's going to be 10 triangles. So we're going to find the area of this triangle, and then we're going to multiply it by 10. Now it says the length side is 20, so I'm going to call this one down here 20. And we have to find the length of the apothem. So let me put the apothem in, and let's see, how can we figure this out? So this is a right angle right there. All right, so here we go. Let's see. So since the apothem, it's a perpendicular bisector of the side, so we can get that this part right here is equal to 10. All right, so we can find the central angle is going to equal 360 divided by 10, which would be 36. All right, measure the central angle is 360 divided by 5. I'm trying to figure out why they divided it by 5 and not by 10. Oh, because how many triangles it is. Duh, there's only going to be 5 triangles. There's only going to be, hold on a second, I don't want to have to start this video over again. One, two, three, four, five, 6. I knew I was doing this right. Okay. So we're going to take it by 10. Oh, no wonder, pentagon. No, here's my problem. Sorry, everybody. Pentagon has 5 sides. I could have drawn that very easily. Okay. So this is going to be, whoops, let's just start over. 360. If I could just remember my shapes, we'd be in good shape. 360 divided by 5, so we're going to get 72 degrees. So this whole angle right here is going to be 72 degrees, but we're actually going to divide that in half to get this angle, which is going to be 36. All right, so we have to find the apothem. So we're actually going to use our trigonometry. So we don't need the hypotenuse, so we're going to use the tangent function because we don't have the hypotenuse. We're trying to find this apothem right there. So we would say the tangent of 36 degrees equals opposite over the adjacent is what we don't know. We'll call this x. That's our apothem. So we're going to put it in your calculator. So we'd say x equals the tangent of 36 degrees times 10. And so we're going to get let's see, of course I don't have a calculator and I did the wrong thing, so it's going to be 13.76 is going to be the tangent. So opposite over that. So x is going to equal 13.76, and that's going to be our apothem. Now we need to find the area of the whole thing. So the area of your pentagon, this blue is kind of gross here, is 1/2 the base of the whole triangle, which is going to be 20, times the height, which is going to be 13.76. And then we're going to take this whole thing, there's going to be 5 triangles, times 5. And so we're going to get the area equals 688 square units. So units squared. And so that's how you find the area of any regular polygon. We might have to use the tangent. Once you find this, it's opposite over adjacent. So that's how we got that. And then we just put it in the triangle formula. All right, let's do the next board. Okay, area of a sector. Let's start out with area of a circle. Area of a circle is just pi r squared, so anyone should be able to do area of a circle. Area of a sector, on the other hand, we're going to go through these really fast. If you just want to find a sector, the area of the sector is equal to this is really the area of a circle, equals n over 360 degrees. So n would be your central angle over 360 degrees. So you just plug everything into this formula, you would end up cross multiplying, and that would give you the area of the sector. Okay, don't want this video to be long. Volume of a cube is just the side cubed. Volume of any rectangular solid, like if we had some sort of rectangular solid like this, it's just length times width times height. The volume of a cylinder is just pi r squared, so that's the area of a circle, which would be the base times the height. Volume of a cube is just the volume of a cylinder times 1/3, because you can, I mean, this is a cone. And then volume of a sphere is just 4/3 pi r cubed. All right, so that's about it for chapter 14.